a little bit ahead of me until like right next to me, and they stuck sharing views.
I'm just fixing up my notes a little bit here because I actually changed the source code of Moodle, and that's after I typed up the notes here. So my own notation is not conforming to the new standard that I put into Moodle. That's why it should look better now. Not that it was wrong before, it's just not very, easy to read. All right, so I'm going to get started. The recorder is on already, and I'll double check to make sure it is actually recording. It is. All right, so are there any questions about the exam on Thursday, after you? Wednesday, that's right, Wednesday. Next class. On Wednesday. So presumably some of you studied over the weekend and looked over the material. So are there any questions that you want me to clarify regarding the topics? It's not going to include any control structure, so it will only go up to subroutines and also expressions. Okay, base conversion, bitwise operators, that sort of thing, but excluding what we are going to talk about today. Are there any questions? Yep, go ahead.
You said there was a practice test, right?
Yes, that was last Wednesday.
You already did it?
I already did it. At least
we
that's.
can't get to it online, right?
Huh?
We can't look it over online.
I think you can. I thought that was what we did. Yeah, it's right here. Exam 1, practice questions. That's what we went over last Wednesday.
Okay.
So if you watch the video from last Wednesday, it will basically include everything that we talked about. All right. Any other questions? No other questions? All right. So if there are no questions, what I'll do today is we'll get back into control structure, and I just fixed up my own note here because the syntax highlighting was on because I modified the source code of Moodle, which made it not recognize that particular span or as an HTML element to be that needs to be formatted. But now it is formatted, so the notes will read a little bit easier. Okay, not that it was wrong before, it was just a little bit harder to read. Okay. So are there any questions about the conditional statement? Because we're pretty much done with conditional statements from last Monday. That was a week ago. No questions? Okay. So what we really need to pay attention to when you're dealing with C and C++ programming is where you put your semicolon. Okay, especially when you do not use open and closed curly brace as a block. Because if you do not use open and closed curly brace as a block, and you specify only one single statement as an expression statement, the semicolon is actually very tricky. It's not as tricky with conditional statement as it is with a loop, which is what we'll do today, starting with loops. The loop slide, as you can see, is pretty short. Okay, this is pretty short, and this is what I was talking about. It's actually correct syntactically speaking, but it's not very easy to read. And the reason why it's not easy to read is because everything is on the same line. In C and C++, you can definitely do everything on the same line, and the compiler does not care. What that means is the line feed character, or what you need to open up a new line, to the C compiler is no different than just a white space. Okay, so that's why when you're writing programs in C and C++, that line is just perfectly okay. Now, if you want me to, which I actually want to do too, is I can fix this up. Okay, so let me just fix this up. It won't take a lot of time. It just takes me a little bit of. I'm looking for a span that starts with syntax, which is right here. I just need to add a class to it. That will fix up that particular problem. And as I said, it had to do with me modifying the Moodle source code, and now it shows up with syntax highlighting and with the correct line breaking. Now, with a while statement, what the compiler is expecting is the following. So when the compiler reads a while statement, it will first find the keyword while, W-H-I-L-E. As soon as the compiler sees this word while, then it will set up certain expectations. And the expectations are as follows. It will expect a condition in parentheses and a single statement. Now that one single statement can be any statement. It can be just an expression statement, which means x equals x plus 1 semicolon. That's an expression statement. It can be a conditional statement that starts with an if. It can be another while statement starting with a while, or in general can be a block statement starting with an open curly brace and ends with a closed curly brace. Okay, because it can be any statement. Are we doing okay so far with what the compiler is expecting? Now, if that's what the compiler is expecting, the simplest expression is an empty expression, which is nothing. So if you put a semicolon with no expression to its left-hand side, it's called an empty expression statement, which doesn't do a single thing. Okay, so let's go ahead and go through some examples to illustrate, how the compiler sees a while statement, because I think it is important to see or understand how a compiler works in order to avoid some of the most common problems with that sort of thing. So I'll go ahead and write some programs here that makes use of a while loop, and it's not showing up well because the projector is still pointing a little too much upwards. Okay, so what I'll do is I'm going to go through a few programs, and you can tell me what the program is supposed to do. And before we do that, okay, we'll just kind of go through this once. A while loop in C and C++ is what I would call a pre-checking loop, which means it is checking for the condition before performing any action. Okay. The reason why I want to call this a pre-checking loop, because most people call this a while loop, is because in Visual Basic, there are different types of pre-checking loop. You can actually use repeat as a pre-checking loop as well. So what this means is the condition of the loop is checked before each iteration. If the condition is true, another iteration is performed. If the condition is false, the loop will exit. Okay, so this is a typical thing that you should have learned already in cisp300 or 301. In the case that an iteration is performed, it does go back to reevaluate the condition to see if another iteration needs to be performed. So are there any questions about the general description of a while loop or a loop that checks the condition before performing an iteration? No questions about that? Okay, very good. So what we'll do now is to focus on the syntax. Okay, that's basically the most important part of this class. cisp360 is really focusing on the syntax of C and C++, not so much the concept, because the concept would still be the same as what you learned in cisp300 or 301 if you're coming from Sac City. All right, so we'll go ahead and write some simple programs, and you guys can tell me what the program is supposed to do. This is a standard template, okay? Because you do have to put all the logic into the main subroutine first, because that's the entry point of your entire program. You need a return 0. Well, you don't need it, but you should have it, okay, at the end of the main function. And then you can now put in whatever code you want to put in. So I'll just go ahead and put in something rather simple. I have a local variable x. I initialize x to 0. And then I say while x is less than, 5, okay? We'll go ahead and do the following. And x gets x plus 1. Okay. So this is not really following my own recommendation of always using a pair of curly braces, because I want to show you what the compiler is actually, how it is compiling or how it's parsing this particular statement, starting on line 5. Starting on line 5, the first thing the compiler sees is the while keyword. And that tells the compiler what it should expect is a while statement. And right at that point, the compiler will say, I'm expecting open parentheses, I'm expecting an expression inside the parentheses that returns either a 0 or a non-zero, close parentheses, and a statement afterwards. That's all it's going to say, okay? A single statement. So it will go ahead and see all of these things that it is expecting, open parentheses, an expression that is either 0 or non-zero, close parenthesis, and when it's expecting a single statement, it sees x first, okay? Is that a keyword that indicates what type of statement this is going to be? Is it a if? No, it's a while. It's not a while. It's not a do. It's not one of the the many keywords that C recognizes. So when the C compiler or C++ compiler sees this, it will automatically recognize and say, since I cannot recognize this as a control structure statement, I will automatically assume this is going to be an expression. And if it is assuming this is an expression, hey, not a problem, because now we have the actual operator. This is the right-hand side of the operator itself, which is also by itself an expression. But this entire thing is just one single expression as far as C++ is concerned. An expression is not a statement, but fortunately, we have a semicolon here, which turns the expression into an expression statement. So now that we have an entire expression statement, this whole thing here, the compiler is pretty happy. It says, okay, I have done the entire loop already, because that's the end of this whole thing. This is the end of the entire while loop, right? So that means if I were to have another another variable here, and I say y gets 10 to begin with, and instead of incrementing, I want y to decrement. So I want y to decrement by 1 for each iteration. That's not going to work. But it will compile. That is the worst part of programming, is it looks like it's going to do one thing, and it's going to do the other one. Okay, it's going to do something that the indentation, that is not what the indentation is indicating. Because the while loop sees the condition, is expecting only one statement after the condition, which is line 8. This is it. So line 9 is actually not a part of the while loop. It is a statement that is simply following the while loop. So that means y is only going to be decremented exactly once after the loop is completed. Are we still doing okay so far with this analysis of the syntax? But the indentation is clearly indicating line 8 and 9 should be a part of the loop. So that is what makes C++ programming tricky, is the end of a while loop is not easily identified. Are we still doing okay so far with this code here? Let's go ahead and run it, okay? And what do you think should be the value of x after the while loop is completed? For each iteration, I first check whether x is less than 5. If x is in fact less than 5, I add 1 to it, and then I go back to line 7 to recheck the condition to see whether x is still less than 5. So by the time I get out of the loop onto line 9, what should be the value of x? Should be exactly 5. And then on line 9, I'm just decrementing the value of y once, which means by the time I get to line 10, y should have a value of 9. Okay, so that's the expectation. We'll go ahead and test this program. So G++-C, well, we can do a warn all. We know it's going to warn about x and y being set but not used. Maybe it won't even complain about that because we did also refer to the values. We'll see. -C, -G, while1.cpp. Yep, did not complain at all. And this time we'll make the executable, and we'll gdb while1. I will just run it once without stopping in between. So I'll put a breakpoint on line 10 and just run the program. So at this point, when I get to line 10, I have no idea whether it considered line 9 as a part of the loop or not. But when I print the values of x and the value of y, it is clearly indicating that line 9 is not a part of the loop. Okay? So if you're debugging a program and it's not working the way it's supposed to, like on line 10, if you thought that line 9 should be a part of the loop and it doesn't turn out to be that way, how would you debug your program? Okay, I'll tell you one thing that I would do if I were to debug this program. I would put a breakpoint on line 7. Okay, so let me run the program again, and we'll see what happens So now I'm stopping or pausing on line 7. When I single step, it will go to line 8. Now, if line 9 is a part of this loop, if I single step again, it should go to line 9. Okay? But instead, if I single step, where does it go? It goes back to line 7. So this is confirmation right here using a debugger that's clearly stating or showing me that line 9 is not a part of the loop. Okay? So this is a really useful tool because you can match up what you expect the program should be doing step by step with what it is actually doing step by step. Are there any questions about the construct of a loop? No questions? Okay. All right, so we'll go ahead and go back to the original program, and this time we'll mess it up in a different way. Okay. So this time I'm going to miss a little semicolon here, which will basically cause a syntax error to happen. So we'll go back to recompile the program. So we'll say G++. I'm not going to put a warn all here because it will report a syntax error anyway. So there we go. Any complaints about expected a semicolon before Y, blah, 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 blah. Okay, fine. So I go back to the original program. But this time, instead of just putting a single semicolon at the end of line 8, I'm going to say, maybe I would need one on line 7 too, because I heard that semicolons are not harmful to a C++ program. All right, so let's see whether that makes any difference. Okay. So this time, in order to fix that one problem of missing a semicolon, I'm just trying to be safe and say, well, let's put several semicolons in here, because it seems like semicolons are not really that harmful. Okay, so let's go ahead and run this program and see what happens, right? All right, so we'll do it. Okay, I'm going to turn on warn all here and see if the compiler is smart enough to catch this one. It's not. And unfortunately, it is not smart enough to catch this one problem. So we'll go ahead and take a look at what happens when we run this program. So just like last time, oops. Oh, I forgot the -G. And then I have to relink and go back to the debugger, list the program, and I'm going to say, okay, I'm going to put a breakpoint on line 10 because I'm feeling pretty good about this program and see what happens. Okay, what do you think is going to happen in this case? It won't exit the while loop, exactly. Okay, it's not going to exit the while loop. So let's go ahead and confirm that. Okay, so we'll run the program, knowing what the program is going to do, or have a pretty strong suspicion of what the program is going to do. We'll run the program, and you're absolutely right. Okay, the program is actually still running, except it's not getting to a point. It's not getting to the breakpoint, and it's not exiting the program. Okay, now when a program does this, when you're writing a program, you can type Control-C on the keyboard to break the program. So you're basically forcibly telling the program to pause execution. It's not really stopped, to the point where you cannot resume execution. You can still single step at this point, but it's telling you that when you press Control-C, the program is on line 7. Okay. So right now I'm going to single step the program. Okay, single step, and it goes into an infinite loop again. It's not stopping. So I type Control-C again. And then we can print x. Hey, x is still 0. It has never been incremented. It has never been changed. Okay, so that means line 8 never executed. And that's because in this particular program, line 8 is not a part of the loop. What? No one seems to be surprised. Alrighty. So that means I'm doing a really good job teaching you guys what the compiler sees, how a C compiler sees the program. That's why none of you is getting surprised. It's like, whoa, what is happening here? All right, but I'm still going to go over what the compiler is doing with this program, especially on line 7. On line 7, which is at the beginning of this statement, the compiler sees the word while, which is telling the compiler, expect the following. Open parenthesis, condition, close parenthesis. That part is not a problem. We have that. Okay. So after the open paren, an expression that returns a 0 or non-zero, in the close parenthesis, the compiler says, okay, I'm ready for the statement in the loop. But instead, it sees a semicolon. So what the compiler is now thinking is saying, oh, I see, you want an empty expression statement because a single semicolon is an expression. Is an expression statement, except the expression itself is empty. It doesn't do a single thing. So this is actually a loop all by itself on line 7 because the semicolon is an empty statement. It doesn't do a single thing. What that also means is line 8 is actually after the loop. It doesn't, it doesn't run like that. Okay, but what if someone's saying, but I'm not convinced that line 8 is after the loop. I think there's something else wrong with this program. Okay, well, let's go ahead and go back into GDB, and we can actually confirm that that is not the case. Okay, so we'll run the program, and obviously it's behaving the same way as last time. Type Control-C on the keyboard, and now it's on line 7 again. But remember, in GDB, it gives you the ability to change the values of the variable as when you're in GDB. Now that is really useful because at this point I can say set var x equal to something. You can also use print x equal to something. It would do exactly the same thing. But I'm just going to give x a value of 5, which is not less than 5 anymore. So now that I have set the value of x, double confirm, make sure it is in fact 5, I single step again. But this time, as soon as I give x a value of 5 and a single step, it got out of the loop and continue on to line 8. So that's basically double confirmation that the program was stuck in an infinite loop because of the problem that we just talked about. Are there any questions about this particular example? So semicolons are not harmless, okay? Extra semicolons can change the meaning of control structures. And it's not syntactically incorrect either, which is one part of the worst part of the problem is it's not a syntax error. All right. Any other questions? No other questions? All right. So we'll go ahead and take a look at this program again, and this time we'll say, attack, you're forgetting something that can make this program a whole lot easier to read and also shorter, which is doing a pre-increment here. Okay, so this time the program this is not going to be an infinite loop anymore, because as we evaluate whether plus plus x is still less than 5, we're also having a side effect of increasing x. So this will actually in fact exit when x becomes 5. Behavior, in terms of behavior, is not exactly the same thing as the previous program, but it is similar. It's not exactly the same. So we'll go ahead and test this program and say, but why would this program exit? It's because the condition itself, which is this part here, has a side effect of increasing x for each iteration already. Okay, and this is one of the things about C++ programs is they make use of the pre-increment or the post-increment operators a lot. So you will find this type of program a lot when you're dealing with C programs. So we'll go ahead and test this program, right? So we'll go ahead and G++-C -G .cpp, and then link it again, and debug it. It's the program. Put a breakpoint on line 7. Run it. Single step, single step, single step, single step. This time it's going to end and move on to line 8. Okay? And by the time we get to line 8, x should have a value of 5, and it does. Okay? So there are also all kinds of tricky things you can do with loops in C and C++. All right. So getting back to my own notes here, my recommendation is not to use any type of statement other than a block statement after the while keyword. Simply because with an open and closed curly brace, one, it is visually clear where is the beginning and where is the end of the body of the loop, and two, you can insert as many statements as you want inside the block statement, and it won't affect ordering of the statements. So we won't have any problem like what we saw earlier. Some people like to put the open curly brace on the same line as the while line. It doesn't really matter to me, okay? It's more or less a personal type of preference in this case.
So you're saying if we use the block statement, we could put two expressions into the while loop, or two statements?
You can put any number of statements between the open and the closed curly braces.
So we could do the increment of x and the decrement of y.
Oh yeah, yeah. Or you can put nothing in it like the way it is. So the way it is right now, with open and closed parentheses with nothing in between, is the same thing as a single semicolon, which is an empty statement. But this is visually more clear. Where's the beginning, where's the end, and you don't have to worry about, oh, it can only have one statement, so the next one is not a part of the loop. All right, so are there any questions about this part? Yep, go ahead.
Do you have multiple statements without those brackets?
You cannot, because of the problem that we just talked about. Because the while statement only expects one single statement after the expression, after the closed parentheses of the expression. So whatever one single statement you put after that is the body of the loop. Now, with all of the other type of statements, you can only have one. But with a block statement, because it's a container, inside the container you can now throw in as many statements as you want, and it won't change what is actually considered a part of the loop. Is that okay?
Yeah.
All right, very good. Any other questions about the pre-checking loop? Any questions? Okay. So if there are no questions about this, you can probably know what type of question I'll be asking in exam 2, not the one on Wednesday, but in the next exam, I'll be giving you like tricky cases like what we just talked about, okay? So visually, it looks like it would do one thing, but in terms of actual behavior, it'll be doing something else, okay? But why am I being so tricky? Why do I ask these tricky questions? Can't I just ask some simple questions instead? Well, the answer is no, because you will end up writing those tricky questions yourself, because as a C++ programmer, at some point, we'll get sloppy, and we'll forget about the open curly brace and the closed curly brace, and we'll make mistakes, just like what we talked about. So you will need to know how to debug your own program when you don't make those mistakes. So for the most part, it's not because I want it to be tricky, it's because those are very common problems that people have when they deal with C and C++. All right, next slide is post-checking, which is a do-while loop. And once again, I fixed this one already. That's good. So a do-while loop is kind of like a repeat until in your previous class if you have exposure to a repeat until. So what we have here is the syntax is kind of like this, okay? It starts with a keyword do, okay, in this case. So as soon as the C++ compiler sees the word do, D-O, it will basically set up certain expectations. It will set up the expectations of having a single statement after do, and then after that statement we have a keyword while. After that keyword while will be a condition in parentheses, basically any expression that can be 0 or non-zero. And then the last semicolon is not, it's actually not expected. It doesn't have to be. That's a good question. I think that one has to be here. Well, we can test that one pretty easily. I think that semicolon has to be there. So we'll go ahead and test this. All right. So that means this block statement here is also not expected. We'll go ahead and write some programs to test a post-checking loop. Oh, let me do one more thing first. The behavior of a do loop is different from a while loop, because what you do is you perform the statement inside between the do and the while first, and then you evaluate the expression. If the expression is true, you go back and do it at least one more iteration. If the expression is false, you get out of the loop. This is also why it's called a post-checking loop, because you're checking the condition after you perform a iteration. Are there any questions about the do-while loop in terms of its expected behavior? You perform the action, then you check whether it's time to exit or not. right. So if there are no questions about this, we'll go ahead and write a sample program to deal with this, to test a do while loop. So we'll go ahead and write a simple program that is almost the same as the one before. We'll start with something simple that does work, but not exciting. So x gets 6 plus 1, semicolon, while x is less than 5, kind of like last time. I think you need a semicolon after this, but we'll go ahead and see if this will complain about it. Okay. So go ahead and do a g++ dash c dash g do 1 p. Yep, we need a semicolon after that. Just one convert. Okay, that's it. Okay. So this program is not much different from the one before, but this one is different in one way. It always increments x before checking the condition. So by the time we get to line 8 to check whether x is less than 5, the first time we get to line 8, x has a value of 1 already, not 0. Okay. All right. So let's go ahead and just check out this program because we kind of know what this is supposed to do already. So we'll go at g++ dash d dash c do 1 p, and then link it, and gdb, put a breakpoint on line 9, run the program, print the value of x, which should be 5, and so it does work the way it's supposed to. All right. So with this particular program, let's see how we can mess it up. The first thing we'll do is, let's see if I can mess it up by having another semicolon after this. What do you think the compiler is going to do if I have 2 semicolons on line 7?
Is that going to be the end of the do statement?
Well, it cannot be because the do statement does expect the keyword while after the one single statement between the do and the while. So what this is going to do is what? It's an error, exactly. It's a syntax error, which is great, okay, because it won't behave incorrectly because it doesn't get to the behavior part. Okay, so let's go ahead and take a look at this code and see why it is a syntax error. And then we'll go ahead and actually compile it to confirm that it is actually a syntax error. Okay, so on line 6, we see the keyword do, which means, okay, set up the expectation. This is a post-checking loop. We have one statement, and then a while, and then the condition, and then the semicolon. You will see this part as the one statement, right? This is one expression statement. So right at the end of this, right after the compiler parses this particular semicolon, it will say, okay, now I should see while, because that's where the keyword is supposed to be. It's right after the one statement after the do. But instead of seeing while, it is now seeing another semicolon. So the compiler is going to complain and say, hey, on line 7, or either line 7 or line 8, I think it will complain about line 7. On line 7, it's going to complain, I'm expecting the word while, but I'm seeing a semicolon. Something is not right, okay? Now that is not the worst thing because the compiler complains about it, you can fix it. It's not going to behave incorrectly in this case. So we'll go ahead and check and see whether the compiler is actually going to complain about this or not. And sure enough, it does. And it does complain on line 7. It says exactly what we talked about before. It's expecting a while before the semicolon, the second one, and it even clearly indicates which one we are talking about because there are 2 semicolons on this line. Okay. Are there any questions about why this is a syntax error? No questions? All right. So it doesn't have as much chances of having the problems that we talked about before, but I would still use open and close curly brace to enclose everything inside a do loop, even if there's only one statement. Okay. Are there any questions about a do loop, which is a post-checking loop? No questions? Yep, go ahead.
So there's no such thing as just like a do loop. It always has a while after it.
Yeah, it always has the word while, so it's always do blah 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 and then while. Yep.
Is there a do until?
No, in C++, there are no do until. So it's always a while, which means a non-zero of the expression means another iteration. In Visual Basic, there are all kinds of variations.
Yeah.
Yep. All right. So now we move on to one of the most commonly used loops in C and C++, but it's really no more than a shorthand of a while loop. Okay. I will present the text here just the way it is specified here, and then we'll go ahead and talk about. I'll change the format so it's more clear, because it will have syntax highlighting for one thing, and it will separate it into lines. But we'll just do it like this one first, okay? So the general syntax of a for loop is, first there's a keyword called for, F-O-R. So for is just the keyword. It will set up the expectations of the compiler, and it will now start to expect the following. What it expects is the open parenthesis. Now this time between the open and the closed parenthesis, we have three components. It will expect the first one to be some kind of initialization expression, and then with a semicolon to separate it, a condition, and then another semicolon, and then what we call a post-iteration expression. So there are three expressions inside the parentheses, separated by semicolons, not commas, okay? Now that is very important, because if you use commas, it's not going to work, or it has different meaning. A closed parenthesis to close the three expressions, and a single statement as a part of the loop, okay? And if you want to look at it, it's kind of like this, except, the body part, this part here, can be any statement. I just use a block statement here. All right. So what about the actual behavior? The behavior of this loop is actually the same thing. If you look at this line here, it's actually exactly the same line here. It will perform the initialization first, before the while loop. It will check the expression before each iteration. In other words, it is a pre-checking loop in disguise. But what is confusing is where's the post, okay? The post operation of each iteration is performed after the body, even though in a for loop, the post seems to appear before the body. It is actually performed after the body. Okay, so is everybody kind of fed up with the way this is displayed? It's not multiple lines, has no syntax highlighting and stuff like that. Now I'll go ahead and fix it. But to the compiler, it doesn't really make any difference. Okay, so you have to remember that. So let's go ahead and fix the syntax of this one, and then we can more clearly see the structure of the code. I need to get into the HTML mode and syntax. So this way I don't have to search for that. There's no global search and replace, otherwise I would do it. I think that's it. I think I caught all of those instances. And now we have our usual syntax highlighting. So what I'm saying is this loop here, this part, is exactly the same thing as this part here. The only difference is, in this case, the initialization, which is happening right before the loop, and the post operation, which is at the end of each iteration, they're all combined onto the first line. Now the reason why we have a for loop formatted like this, even though we can do the same thing, exactly the same thing, using a while loop, is because typically speaking, the initialization before the loop, the expression that you evaluate for each iteration, and the post operation of this loop, these three are usually related, and that's why they're put together so that you can clearly see, okay, how do we initialize, what do we do before we get into the loop, how do we check whether we should get out of the loop, and what should we do at the end of each iteration. So that's why these three are put onto the same line. It's just because they're related. Are there any questions about the syntax of a for loop and also the semantics? This is the syntax, and that's the semantics. That's basically what it will actually do. Any questions? Yep, go ahead.
Doesn't it say that the initialization is a local variable? So should
It can be anything. The initialization can be any variable defined up to that point, and you can also define additional local variables with the initialization. But that's only C in C++. In regular C, you cannot do that. All right, so let's go ahead and write some code with a for and see how it can do the same thing as a while loop. All right, so we'll go back to while1.cpp, kind of fix this up a little bit so that we get it back to the original shape. Okay, so we'll x gets x+1, and we use open curly brace here, close curly brace here. Okay, so this is actually my original intent of this what this program is supposed to do. So you can see that x will increment to 5, y will decrement to 5 when we get out of the loop. So we'll now go ahead and look at this program and look at the for loop version of this program side by side. So let me just do it that way. So I think it's dash uppercase O to display something side by side in VI. Yep, it is. Okay. So on the left-hand side, we have the while loop version, and then on the right-hand side, I'm going to write the for loop version of exactly the same thing. So we'll go ahead and do the usual stuff, main. And this is the way I write my programs. I always close the curly brace as soon as possible, and then just go back to fill in the content. Int x, int y. And instead of putting the initializations, which are line 5 and line 6, individually before the loop, I'm going to do this. So I will say for, and in this case I have x equals 0, y equals 10. And you can see how I use a comma to separate the two initialization expressions, because they're both for initialization purposes. If I used the semicolon, then it'll be separating the initialization from the condition itself. So that's why in this case you have to use a comma, because it's only expecting one single expression. But how can you initialize two variables in one single expression? We use the comma separated expression, right? So in this case, the comma, this is one, okay, let me highlight what I mean by that. This is one single expression right there. It's a comma separated expression, which we have encountered the first time we talked about post increment. Is that okay so far? Is everyone convinced the highlighted portion is one single expression, or can be seen as one single expression, using a comma as an operator, basically? Okay. And then now we actually use a semicolon to separate the first expression, which is for initialization, from the part that determines whether we should get out of the loop or stay in the loop. In this case, it's really just x is less than 5. Okay, so x is less than 5 is the only condition that we have to do in here. And then the post operation is kind of up to you. Okay, so we can use both post operations, which means I can put plus plus x and plus plus y as a post operation, because plus plus x is kind of what line 9 is doing. Plus plus y is kind of what line 10. Oops, take it back. Minus minus. Okay, minus y is kind of what line 10 is doing. Oh, well, then what do we have to do actually in the loop here? Nothing. Right? Because I have done everything in the initialization, the condition, and the post operation of a for loop already. So there's nothing I need to specify as a body of the loop, at least not in this particular case. So I use a single semicolon to close the for loop, and as far as the compiler is concerned, the one single statement of the for loop is a semicolon, which is an empty expression statement which doesn't do a single thing. which is fine because I'm doing everything with the post operation itself already. Put the return 0 here. So now I'm claiming these two programs behave exactly the same way. There's no difference whatsoever as far as the behavior is concerned. The syntax, yep, they're very different, but in terms of behavior, they're exactly the same. Is anyone buying that? No? All right, so let's go ahead and test this, okay? There are several versions of this that we can actually test it with. Okay, so we'll go ahead and test this program, g++-1all-c-g or1.cpp. Oops, wrong file to GDB. Go. All right. So I'll just be brave and put a breakpoint on line 6. Run the program. Now I'm on line 6. Print x, it is 5. Print y, it is 5 as well, which is what you would expect the program to do. All right. Now let's go ahead and change this program a little bit and say, but what if we put something into the body of the loop? Okay, so we'll go ahead and say, let's not make this an empty statement. Instead, we'll make it a block statement. So inside the block statement, I'll move minus y to here, and as a result, I don't need it to be there anymore. So now the question is, do I perform line 7 first, or do I do the ++x first for each iteration? That's the question. In terms of the ordering, it seems to suggest that we'll do the ++x before the -y in each iteration. But that is not true, okay? Because the ++x is supposed to be the post operation of each iteration, which means we're going to perform the statement from line 6 to line 8 first for each iteration. After that, we'll go perform the post operation, which is the ++x. Okay? Well, we'll go ahead and check it out. And we'll also check out, in GDB, what it is going to look like when we single step this particular for loop, because it's kind of a little awkward, but we'll see. So we'll go ahead and compile again. And link GDB. And this time I put a breakpoint on line 5 because I want to single step throughout the entire loop. Now I'm on line 5. Double check. X is actually 0 already. This is before I actually do the initialization. Y has some gibberish here, so that's because this is before I perform the initialization, this part here. So when I single step, it will perform the initialization, and now I'm on line 7. So print x, print y, kind of what I expect it to be. Single step, and it goes back to line 5. But what the real question is, we know y is decremented already, but what about x? X is not incremented yet. Okay, so if I single step one more time, it will do two things. It will first increment x, which is the post operation of each iteration, and it will evaluate x is less than 5. So by the time I single step, when I press the enter key here, it's going to be on line 7 again, okay? Because it will combine the post operation and the evaluation of the condition into one single step. That's why. However, if I print the value of x, what should I see now? Should be a 1. Yep, exactly. So if I do this 5 times, okay, so that's my 3rd time, 4th, this is the 5th time, and it exits. Okay, so when you single step this kind of code in GDB, you have to be careful because ++x and x is less than 5, they're both on the same line. There's no way to separate the evaluation of those two expressions. So it's combined into one. Okay. Now I'm going to try something that I have not tried before. Okay, so what I'll do is I'm going to say, if I separate these things into different lines, will the debugger, go back to each individual line so I can single step through a for loop in smaller steps? Okay, that's the question. So we'll go ahead and see if this will change the behavior of GDB. Now, if you're not using GDB, this certainly has no meaning whatsoever. Because remember what I said at the beginning of the class, line feed, or what you use to separate a line into two, is nothing more than a white space as far as the compiler is concerned. Okay, but to GDB, it may make a difference. Okay, I don't know yet, so we'll go ahead and check this out. G++-G-C401.cpp, and then we link it, and then go ahead and put our theory to test. Okay, break on line 5, just like last time. Run it. Now it stops on line 5. Single step that will go through the initialization. Now the condition is definitely not being tracked individually. So I think the behavior is going to be the same thing as last time, except when I single step from line 9, it will go back to line 7 in this case. Nope, it considered the entire thing as one single thing, so it's just line 5. So it doesn't really help, unfortunately. So by the time we get to the last iteration, which is, let's see, not here, one more time. Okay, this is the last iteration because y should be 6 at this point, and x should be 1 at this point, or 4 at this point. So when we single step one more time, it will decrement y, go back and increment x, check the condition, and exit the for loop all in one single stroke. So that's why, okay, one more time, and it gets out. In other words, separating the 3 components of a for loop into different lines is not going to help you when you're tracking it, when you're debugging it. Are there any questions about the for loop? Go ahead.
So if the post can do the whole operation of the loop itself, then why do we have the for?
Okay, typically what people do with a for loop is they focus the condition and the post operation. Okay, I take it back. The post operation usually only has to do with whatever you use in the condition itself. Anything other than the condition, you should do it in the body. And then most of the time, you also have a lot more code in between, so it won't even fit into the post operation part. But that's a good question. For simple for loops, yeah, you can absorb everything into the post operation and have nothing specified as quote unquote the body of the loop.
My question is sort of the opposite. Can you have just a body without a post expression?
Yes, you can. Each individual component can be empty. So if you don't have anything to initialize, you can just have open parentheses and have a semicolon right there, which basically means there's no initialization. If you have no post operation, you can have the second semicolon and then the close parenthesis following, right next to it. Then you're specifying there's no post operation. You can even specify no condition, which is this is the only kind of loop where you can specify no condition. What do I mean by that? Okay, so let's go ahead and take a look at a different for loop here. Oops. Well, actually, for this one, it's easy. That's a program. It is syntactically correct. Okay, so what it means on line 3 is a for loop, right? So let's see what the compiler is actually seeing in this case. On line 3, the compiler will first see the for keyword, and it will set up the expectations of open paren, initialization, semicolon, a condition to evaluate, so it knows when to get out, semicolon, post operation, close parenthesis, and a single statement after that. And it's seeing the open parenthesis, no problem, but before it can see any expressions for initialization, it sees the semicolon already. But you know what? This is a valid expression. It's called an empty expression. So that means there's no initialization. Between the first and the second semicolon is expecting a condition. But again, there's nothing here. Now, this is the only type of loop where if you do not specify a condition, it is just true itself. Okay? So if the condition itself is true, when does true become false? Never. True never becomes false, which means this is an infinite loop. This is the quickest way to write an infinite loop, is to say for in two semicolons in parentheses. Between the second semicolon and the close parenthesis, there's supposed to be some kind of post operation, but that can be empty as well. So there are no post operations. Okay, after the close parenthesis, which is what the highlighting part is, which is the part that is being highlighted, it's expecting a single statement. What kind of statement do we see here? An empty statement, because it's just a semicolon. So this is a very tight loop. It's not going to exit. Are we doing okay so far with this kind of weird syntax? So each component inside the parentheses can be empty. In other words, they're all optional. Are there any questions about a for loop? Yep.
And that's just for the for loop, where they can all
That
be
is
empty.
just for the for loop. With a while loop, you always have to specify some expression between the parentheses. And do while is the same way. Between the parentheses, you always have to specify something. This is the only time when you don't have to specify anything. So just to confirm, just so that I'm not making any assumptions, that's what it compiles just fine. So syntactically, it is correct. Now, if you do a warn all, it will probably complain about it. No, maybe not. If you combine the warn all with optimization 1, nope, even that does not complain. That's weird. Because I was expecting the compiler to complain and say, hey, the return statement is unreachable because we have an infinite loop before the return statement. And it might have to do with, I don't know. I have seen cases where the compiler complains about a certain statement is unreachable, which is the case in this particular case. But it doesn't complain, so you have to kind of watch out. Are there any questions about a for loop? Yep.
So one of the first conditions is initialization. In the initial, in that part, can a variable be declared?
Yes. In C++, the answer is yes, but in regular C, the answer is no. Let me show the whole class here what I mean by that. So let's go back to 4.1. So the question was, can we declare a variable and use it right away when you're inside a loop? And the answer is yes. So you can do something like this if you want to. And I think with this we have to specify that too. So you're basically declaring and initializing at the same time. Now, but with this, it's tricky because any code that is not from line 3 to line 8 in this case cannot see x or y. The scope of these two local variables are now limited to inside the for loop only. So nothing outside the for loop can actually see these two local variables. But you can do this in C and C++. Well, excuse me, you can do it in C++, but not in C. So what that means is if I use G++, this program is compilable. All right, it doesn't like it because of the extra int. Okay, we'll fix that. It's because of this extra int, it doesn't like it. So in G++, it is okay. Now, if I change the program, if I copy this program to just a regular .c and use, specify .c here, and then I use GCC instead of G++, and then use the version that is ending with .c, that's not okay. So this is one of those kind of minor differences between C++ that makes it, somewhat different from C enough that you would think that it should work, but it does not. All right, any other questions? Okay, I forgot two things that are really important. The first one is a row sheet. I forgot to take row in the previous class, so that's why I put a big, long bar on the column. And the second thing is you have a new homework assignment. I forgot about it altogether. Your new homework assignment is found in control structures. Okay, it is called find max 3. So guess what it's going to do? Finds the maximum of 3 variables. That's right. Okay. So here's your homework assignment, and I put it in boldface here because apparently some people are still kind of not getting this part right. Okay, be careful about the names of the files and the folders, because the submission that deviate from the description cannot be picked up by the grading script. I really don't want you guys to lose any points over this, but it is kind of important, okay? So be sure to use the right name for your files and your folders. Okay, but this is the program. This entire program starts from here and it ends here. What you need to do is to insert code in between here. This is the part where you insert your code, and you cannot use any ternary operators. So this time you have to use conditional statements, okay? So this is basically, because this particular homework assignment is in control structure, the topic, so that is the focus is to use control structures. You have to use, I'm not going to tell you which control structure you're going to use. There are 1, 2, 3, 4. There are 4 types of control structures that we have talked about. There's if, while, do while, and for. So you kind of have to decide which one you should be using in order to find the maximum of 3 variables or 3 parameters in this case. So x, y, and z are all parameters. Your code has to refer to x, y, or z, update max as a local variable to the maximum of the 3 parameters, and then return it. So you don't have to do anything about line 7. It's already done for you, and you just have to insert as many lines of code as you think is necessary instead of line 5 and 6. Are there any questions about this? No questions? Are you guys getting a general idea of how to do this? There are quite a few ways to do this, okay? So it all depends on what you feel more comfortable about. Okay, so if I give you 3 numbers and you want to do it by hand, how would you pick out the maximum of 3 numbers? Well, you can do it, what we call the eyeball algorithm, which is not helping. Okay, the eyeball algorithm simply means that you can just glance over 3 numbers and pick out the largest of the 3 numbers right away, and without using any systematic way of looking at things. But remember, when you're comparing, you cannot do something like this. Okay, there's no such thing as this is not a valid syntax in C or C++. So you cannot do it this way. So how do you make this work? There are 3 ways to do this. So I'm going to just illustrate the 3 ways to do this on the whiteboard, because it's just a little bit harder to use my text editor to illustrate this. There are different ways to do it. The first way is to pick any 2 variables. Pick any 2, establish the order between these 2. Now, this can either be true or false, right? Cannot be any other. So you say, okay, what if this is true and what if this is false? If x is less than y, then you have something else to do here. Okay, if x is less than y, that means x cannot be the maximum. So now you have to say, well, let's figure out, between y and z, which one is larger. Then we'll also give you 2 extra cases here, and by the time you get to this part and this part here, you know exactly what to do. Is that okay? Making any sense? On the other side, if x is less than y is false, that means they're either the same or x is greater than y. But in either case, you can throw out y and say, let's just take a look at x. Does that make any sense? So on the other side, you just have to compare x and z. And out of this comparison, you also have 2 cases, and you should also know what to do with with these two cases. That's one way to do it. Now, if you want to do it this way, you will have to nest conditional statements within conditional statements, which also means using the extra curly braces can be useful to make your code easier to read. Once again, it is not necessary, but it will make your code easier to read, and the semicolons won't basically get into your way anymore when you do it this way. The other way to do this, go ahead and erase this. And by the way, what I just drew on the whiteboard is called a decision tree, because at each point you have a condition to evaluate. Based on the condition, you make a decision which way to go, and then whatever branch you go, there'll be another decision to make, and so on. So the other way to do this is to say, if blah 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 blah, which is a confirmation that one of the three variables is the maximum, then you can say, okay, if this condition is true, I'm going to say max is x. Okay. Well, in the else part here, it will be between y and z. So now we can have another conditional statement here that says if blah 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 blah, that confirms that y is the maximum. Okay, so you have open curly brace. And here you say max is y, and here you can say max is z. So this is the other way to do it, is simply to have one condition to confirm that x is in fact the maximum. Then you can just say, okay, max is x. Otherwise, if x is not the maximum, then you have another comparison here to confirm that y is the maximum or z is the maximum. Different structure requires different types of conditions, but it's up to you to decide how you want to do it. How do you test your code?
Debugger.
You can use the debugger, and then in the debugger, you can call the subroutine as many times as you want to without recompiling anything. Okay? How would you test a program that is supposed to find the maximum of 3 variables? Now, I would at least test these cases, okay? 3, 2, and 1, right? 1, 2, and 3, 2, 3, 1. What am I missing here? 1, 3, 2. So you can go ahead. There should be 6 of these, right? Okay, I've got to do it more structurally. 1, 1, 2, 2, 2. I think it's just 1, 1, 2, 2, 3, 3. 1, 1, 2, 2, 3, 3. Because once you lock down one position, you only got 2 choices for the second one. So 2, 3, and it locks down the third one as well. So this was 1, 3, 3, 1, and 3, 1, 2, 2, 1 over there. So those are the 6 permutations. So I would test at least those, and then you can have the same values too, right? So what if I give you 3, 3, and 3? What is the maximum of 3, 3, and 3? That's just 3, okay? What about the maximum of 3, 3, and 1? That will also be 3, okay? So it's up to you guys to test your program thoroughly to make sure that it does work in all cases. Okay? All right, so in today's lab, what I'll do is I'll give you some hints of how to test your program so that you don't have to, you can write a script to do it. So once you figure out all the test cases, you don't have to hand type every single one each and every single time, because that's going to be tedious. Okay, so I'll show you a trick to basically make a script for GDB so all of these testings can be done automatically. So it will come in handy, okay? Because that's also how I grade your homework assignment. Is I will basically subject your program to a particular test script that will test out all the cases. Are there any questions about this homework assignment? Does everybody have a general idea of how to get started with this one? Yep.
So for that first if statement, you said at the beginning you can't compare x, y, and z in the same statement, right?
That's not what I said. Okay, so that is not exactly what I said. What I said was, hopefully this one feels like it still has ink because it's heavier. What I said was this cannot be used as a single expression. That's what I said. But you can break it up into two expressions with a logical operator in between. So I'm going to leave it up to you to decide how to break this up into two expressions with a logical operator connecting the two comparisons. Yep.
They should be only 2 lines, 5 and 6.
Oh no, you can use as many lines as you want to. Yeah. So the thing is, you don't want to change how I declare max, and you don't want to change return max. But in between, you can have as many lines as you want. But since the C compiler sees end of line as a single space character, if you want to make it really cryptic to read, you can type the entire thing on one single line. I don't mind.
Okay.
Are there any questions at this point about this particular homework assignment? Questions? Okay. If there are no questions, we are going to move on. We're done with control structures, really. Okay. Now there are more control structures than what we just talked about, but for the most part, I'm going to ignore those other control structures because they're not 100% necessary, and sometimes they kind of just get in the way. So after control structures, we are now getting back to libraries and modular programming, which we have already talked about already. So we'll just go ahead and find out. I don't think there's anything here that we need to go over. So now we'll start on scope and the lifespan of variables, which we have already touched on before. Up to this point, all the programs that I write do not make use of global variables. In other words, the declaration of all the variables are always inside a subroutine definition, never outside. Okay, you should do the same thing. Okay, so in other words, up to this point, you should not have to write any programs that require the use of global variables. There are very, very few uses of global variables, and at this point, we have not encountered any one of those needs yet. So I'm going to defer the discussion of global variables until we actually need to use global variables. In some other classes, people talk about scope and the use of global variables, and unfortunately, people just pick up and say, oh, there are global variables. I'll just go ahead and use global variables. So instead of doing that, I'm just going to say we cannot declare global variables because we don't even know the syntax of doing it just yet. So with that in mind, I'm skipping this whole topic until it is time to talk about it, and instead we'll be moving on to input and output files. And this one starts with a somewhat non-technical discussion. It's non-technical and technical at the same time. Okay, and the first question is, what is a file? What do you think is a file? I mean, go ahead. You guys can tell me. What is a file? Say again?
Put stuff in.
Okay, you can put stuff in. Okay, so what happens to that stuff when I turn off the computer and then turn it back on again? It will still be there, right? Okay, so that's one general perception of what a file is. Okay, since a file is something that you can put stuff into, how can I differentiate one file from another file that you put different stuff into? Okay, so each file has a name. Okay, very good. So, so files have names. They are persistent. Okay, so they do not go away. They're not volatile. When you turn off the computer, the content of a file is still there. Very good. What else do you know about files?
They can contain other files.
A folder can contain other files, but a file cannot contain other files. What you just said is kind of interesting. Okay, let me just kind of repeat what you said. What you said was a file can contain other files. A folder is actually really quote unquote just a file in a file system, but it has special attributes as well. So that's a good question, but I cannot address that particular part in this class. What else do we know about files? Come on. You guys can. What do you do with a file? Come on, that's the most important part. Go ahead. No, go ahead. You can execute a file. That's one way to use a file. What else do you do with a file? You guys are missing the most important two operations that you have to do with a file. Without those two operations, files are pointless. Read and write. Okay, thank you. Okay, so those are the most important two operations associated with files. Is you can read from a file and you can write to a file. Everything else, as it turns out, is not really a necessary attribute of a file. What? You mean a file does not need to have a name? Yes, that is correct. Okay, I should say no. A file does not need a name. What about the other one? Oh, you have to be able to save a file, so when you turn off the computer, the content will still be there the next time you turn it back on. That is also not a necessary attribute of a file. So you just nailed it. Okay, the only two operations that are truly native and necessary to a file is reading and writing. Now, some files can only be read and some files can only be written too. But it has to support one or the other or both in order for a file to be useful. So are there any questions about what I just said? No one is wondering if a file has no name, how do we get to it? Or if a file does not store any content, what is the whole point of having that file? Nobody cares? No? Not really? Okay. All right, so what I'll do is I will use the remaining 3 minutes or so to illustrate what I just said, okay? Those, what the heck is a file? Okay, there's a program called WC, which is not what you think it is, especially if you're European, what it is, okay? WC is not water closet, which we call bathroom or toilet. WC stands for word count, okay? So what you do with word count is you can give it a file and it will count the number of words, the number of lines, and the size of the file in terms of number of characters. That's what it does. So I just ran the program and it seems like the program is getting into an infinite loop. It doesn't seem to be doing anything. But it is just asking me to type something, okay? So I'll just type, this is a test of what WC actually does. I wonder whether this program will ever exit. Okay. So when you're dealing with something like this, WC is actually reading a file right now. Okay? But I didn't tell it what file to read. It's called standard input file. And with every C and C++ program, there's always a standard input file, which is normally mapped to what we call the keyboard, okay? So that means what I just typed here is the content of the file that WC is reading and count the number of words, the number of lines, and the number of characters, okay? But it doesn't seem like there'll be any end to this. In Linux, when you want to end a file like this, when you're typing it interactively, you type Control-D on an empty line, and that will basically mark the end of this file. So I'm just going to type Control-D on my keyboard right now, and then it returns, there are 2 lines, 17 words, and 89 characters that I just typed. That is a file. Okay, this file has no name. Right now it's gone completely. Okay, it's not stored on a hard drive or an external hard drive or a thumb drive or any kind. But it does serve the purpose, one of the 2 things that we mentioned, right? Because this file was read by the program WC. Okay, let's go ahead and run another program that you're quite familiar with, or should be familiar with. It's called ls. What does it do? It shows the content in the current working directory, right? Or whatever directory you specify, but if you don't specify which directory, it's going to be the current working directory. Okay, not really surprising. The backslash is because I mistakenly typed type backslash when I save a file, but it's just showing you all the files here. What if I tell you that I have already illustrated the use of files at this point? Just running ls all by itself. The output of what you see here is a file. except that file is not saved anywhere on your hard drive. It does not have a name, and it is simply printed to the screen, quote unquote screen of your terminal. That is a file. Yep.
I just need to understand a little bit more. So what you mean by this is that every time you're writing any command on there, as long as, even if you don't name it, that's going to be considered as a file?
Yes. So let's go back and revisit a program that we have done before. Remember this? Or something to the same effect. I'm just going to shortcut this here a little bit. This Hello World program is making use of a file. It's an output file, okay? In other words, the file is written to by the program hello. But where's the file? It doesn't have a name. It's not stored on the hard drive. The content of the file is simply output and displayed on your terminal. But that is actually a file. Okay, well, but isn't that kind of pointless? Because you can call it a file, but what is the actual use of something like this? Well, in Linux, this is the last part I have to demonstrate because I just want to leave you with the thought of this. In Linux, what you can do, actually you can do it in Windows too, is you can send the output of a file into the input of another file using the vertical bar symbol, which does not mean bitwise OR in this case. In this case, it's called a pipe. Okay, so a pipe is taking the output of hello in this case and feeding that file as the input into WC. So when I press the enter key, it should tell me that there is one single line, 2 words, and I guess some 10 characters or so. There we go. Are we doing okay so far with this? Now I can even do something like this. I can take the output of the first WC and send it into the second WC, which will report as 1 line, 3 words, and I guess maybe 6 characters or so, depending on whether tab is used. So let's find out. 24 characters, because these are actual individual spaces, so it counts every single space. Okay, but that is the essence of a file. It doesn't have to have a name. It doesn't have to be stored anywhere on the hard drive. It only needs to support at least one of the 2 operations, a read operation or a write operation. Some files can support both operations at the same time, but it has to at least support one of the 2. That's a file. Okay. I'm going to stop the lecture at this point so that you guys have a chance to go to the bathroom, get something to eat. During the lab time, what did I say about the lab time?
You can show us how to do to check everything.
Oh, how to check using a script. Okay, so that's exactly what we'll do when we come back to the lab time. Okay, so I'm going to stop the recorder at this point, and you guys can go take a break or whatever.